thanks for joining us again today. Sean has a question for me this time.
Yep, okay, so given an integer, print an English phrase that describes the integer.
So given an integer, print an English
Print it in
phrase.
English.
Oh, so would that be, so if I had 0, it would be 0,
Yeah.
1 would be 1, and so forth.
Yep.
Okay, so this, first of all, what's the range of integers?
Let's say
Negative numbers or?
less than 1 billion.
Okay. Wait. And
So,
negative numbers included, or?
let's just say positive numbers for now.
So, less than 1 billion.
Including 0. So this, yeah.
And including, and not
No,
including.
no including 1 billion. Just so anything less than 1 billion.
Okay. Can I pre-compute this?
How would you pre-compute this?
So,
as in,
so what am I? So, what am I using this for?
You're using this for,
like, if I could pre-compute it, maybe I would store it in a database where I would have a corresponding entry for each value.
Mm-hmm.
Like basically something like this. The trade-off would be that I have to store, well, storage basically.
Right.
But the runtime would be just constant time.
Yep.
And you can also argue that. No, actually, yeah, I stand by what I said.
Okay. Let's say something that runs in constant time and constant space.
Okay. So in that case, maybe I'm looking at the digits in the number. And so 1 billion, so here, that means my numbers can have at most, this is 1 billion, 10, no, yeah, so it can have at most 9 digits. So the digits would be 1, okay. And so ignore, so I'm going to look at the edge cases later, like special numbers. So that would be like, say, 20 or like 13, right? Because they don't follow the so-called rules. So the ones that follow the rules would be like, say, 44, right? Because 44, that would be following the rules. So, or do you need me to elaborate on this?
No, I don't.
Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically we would have, up to 9. So this is, oops. So this is, so first of all, let's look at numbers with only 1 digit. I would just map them, So for all numbers, I know it would end in one of these English words. So maybe, except for special cases. So for example, if I had 999, I know this is actually, 9, right? So it would be something, something, 9. And so cases where this isn't true, except for the numbers from 11 to 22, except for the teens. So I think the teens are the only ones where these numbers aren't, these endings aren't used. We also have, let's say, numbers with the last digit being 0, and actually, actually, 0 here is a special case, because if you have something like, say, 10, or 20, 30, this is essentially ignored. We're actually just looking at this, right? So if we compare 20 and 21, we're looking, so 20 and 21, we're looking at 20 and then nothing here, and then 21, right? So, so given this, I think each of these place digits, okay, I think there are some special cases that have to do with the last 2 digits, but anything that's not included in those digits actually follow a pretty standard set of rules. So the largest digit is 999 million. Well, actually, it's this, right? So if we ignore the last 2, basically we're looking at the number and then looking at what place this is. So this is 100 million, right? This is, so actually we're looking at it in groups of 3. So 100, 90, actually, so I take this part back. So we're actually just looking at groups of 3. So we might, we're looking at the group of 3, and we're giving it a number. So here it would be 999, right? And what is this? It's a million. So we add million to that, and then we look at the next group. It would be maybe 136. This would be 136. 136. And then the group, this group would represent 1,000, right? So this is 136,000. And then the last group is, well, we get its value, and then we don't do anything because it's just there's no larger unit to that. So essentially, what we would do is, I think we can break this up into 3 groups of digits, and then if, say, it doesn't have 9 digits, maybe it has 7 digits or 6, we just adjust it accordingly. So maybe if it's just 7 million, we can treat it as having zeros in front and we ignore it. So basically, we only need to come up with translations for numbers from actually ignoring the special cases. We only need numbers from 1 to 999, and then we add the special units to that. To simplify this, we know, so for the 3 digits, we can break it apart as such. This would be something, so like we would look at this digit, and if it's 0, we don't do anything. If it's 1 to 9, then we say it's whatever that digit is, and add 100 to that. For this one, if it's 0, we don't do anything. If it's 1, then there's some special rules for that. Otherwise, it's, again, we give it whatever, so it could be 20, 30, 40, 50, 60, 70, 80. And then for the last digit, it would be from 1 to 9. If it's 0, we ignore it, except for special cases. So the special cases we have would be 11, 12, 13, 14, 15, 16, 17, 18, 19. So basically that would be dependent on this middle digit. So we wouldn't have to store a lot of data for this. We would just need to store the special cases, and then the values for 1 to 9, and then the values from, and then the tens values, so like 10, 20, 30, 40, so forth. And then also we would need to have the values million, hundred, million and thousand. So essentially, all this can be considered constant storage because it's not going to change even if the input gets larger. We're still going to have to store these strings. And then, so actually I want to add something. So if we had pre-computed this, we could say that we're still using constant storage because we're still storing the same amount of stuff in the database, no matter what the number is, right? We still,
Yeah,
yeah,
that's technically correct. Yeah.
but so back to this solution. Constant time would, sorry, the time complexity would be also constant because you're doing like nine sorts of operations at most for like each number.
Yeah. How would you organize that in a code? Like, probably not code the whole thing because it's a little bit tedious. But how would you, I guess, organize this data?
Can I ignore the special cases or assume that they're...
Sure.
Okay, so
I'll give you a hint. Treat the special cases as if they were the single digits.
So
I guess
I'm mostly concerned about the teens here.
Right. So let's see. So the only time where you have modular, I guess, like tens to ones is like when it's above 20, right? 20 and above.
Okay. So I guess...
So we treat the special cases as if they were just single digits itself. So maybe you have just the number 1002, right? 1002.
Yeah.
Treat it the same as if you were right 1011. In that sense.
Got it. So if the number is from... Okay, to make it easier, if the number is anywhere from 0 to 19, then I would just give it I would just hard code the value. Otherwise, I would do some concatenation. Even though I don't need to do it for 1 to 9, I think that would make things simpler. So first of all, I would break the number into... Okay, so first of all, I would convert the number to a format where it has 9 digits. And so if the beginning is so if it's like not, if it's less than if it has less digits than 9 digits, then I'll prepend the first digits with I'll prepend it with zeros basically, so that it's 9 digits. So let's say 1 million would be this, and then I would split it into groups of 3. So let's say if I'm looking at 1 million, actually if I'm looking at, let's say I'm looking at a number like this. Let's say I have 3, then I'm going to split it into groups of 3. and deal with them separately. And so for the first group, I see 1, 2, 3, right? So this is so this is larger than. Actually, I'm gonna do it.
So,
an
so say you store each chunk, right,
Yeah.
as its own string.
Mhm.
What data, I guess, data structure or storage would you use to make sure? Let's say if you just have 1,000, if you're prepending a bunch of zeros to the end of the 1,000,
Yeah.
like how can that be? I guess is intuitive. Instead of saying like 0, 0, 0, 1,000, 0, in that sense.
I'm not sure if I understand that correctly.
So, I guess how would you parse 1,000?
So instead of converting it to always 9 digits, you could convert it to either 3 digits or 6 digits. Or so I guess it would be rounding it up to either 6 or 3 or 9.
Okay.
And how you would do that is you can you can mod the number of digits by 3. So for example, if you had 5 digits, you mod that by 3, you get a remainder of 2. And so basically, you need to add one more for it to. Wait, sorry. Yeah. So you need to add one more to that number. So is
there a way you can? So in what chunk order would you tackle it? Let's say you have 1, 2, 3, 4, 5, 6, and 7, 8, 9. Would you do the 7, 8, 9 first, or the 1, 2, 3 first?
I would do the last few digits first, and I think I would use something like a string builder so that I would be working with an array of characters. So that so basically check to see, check the string value for the last 3 digits. And then after I'm done with that, I move on to the next 3 digits. And and then after that I move on to the next 3. So basically I'm adding to the beginning of the string.
Okay. And how would you move to the next 3 characters in this code? You don't have to code it, just kind of explain it.
Divide it by 1,000.
Okay.
Yeah. Or, divide by 1,000.
Okay.
That's how I would do it. And then, so, yeah, sorry, so even if I divide by 1,000, let's say if I divide 1,000,000 by 1,000, I would still get 1,000. So the thing is I wouldn't divide by 1,000, right? I think I would mod this by Yeah, mod by 1,000, I think.
Mm-hmm.
And then, so if I modded it by 1,000, let's say if I had 20,000, right? And if I
Mm-hmm.
mod that by 1,000, I should get 0. But let's say if it was 20,023, then if I modded it by 1,000, I would get the last, essentially, the rest that's less than 1,000. So.
Okay. Yeah. So
then,
let's say I give you a function that takes in 3-digit number,
mm-hmm.
or a maximum of 1 to 3-digit number, and just converts it into a string. So, so for like 1 million, you have 3 chunks.
Yeah.
And it magically just gives you a string back.
Okay.
And say this function is called convert chunk and returns a string.
I see
you use that in a. So can you actually jump into coding and use that to help you out?
Convert chunk, right?
Yeah. That's the tedious part, or slightly tedious part.
So if I had a function called, so it would return a string, right?
Mm-hmm.
And I would be giving it
a maximum of a 3-digit number.
Okay. Okay. So, given that, I would, so I want a string of string convert number, right? And this is a number from 0 to 900. So 9999999. Okay. Okay, so let's start with the first so actually I'm gonna start with the first, so the most significant digits, and move on to the less significant digits. So actually let's split it into groups of 3 first. So int group 1 int group 2 int group 3. So group 3, I know, as we established just now, is number modded by 1,000. And group 2 is actually anything less than 1 million, so that would be modded by 1 million. Wait. Modded by 1 million divided by 1,000.
Okay.
And let's check to see if this is right. So let's say we have a number 789,123. And if we want to get 789, we mod it by, so let's say this is it. So we mod it by 1 million. If we mod it by 1 million, we get just 789,123, and then we divide it by 1,000, giving us 789.123. But then since this is like rounded off, we get 789.
Okay.
So group 2 works. Group 1, it's the number divided by 1 million. Essentially, you're trimming off the last 6 digits.
Mm-hmm.
Yeah, and then so basically, these numbers will either be 0 or if there's nothing there. So so convert chunk. So let's actually look at it this way. If group 1 is 0, then we don't do anything. Or actually, how do we do this? If group 1 is not equal to 0, then we want to convert chunk, group 1. So this is, sorry. So this is actually a string builder, dot append. So it's sort of laggy.
Do you mind if I run to the restroom really quick?
Sure. Should I wait or should I?
Keep
I'll
going.
wait.
Keep going.
Well, I'll have to explain it to you, so I'll just wait.
Okay.
Actually, I'll set it up on Atom, and you can let me know when you're back. I won't change the code for now.
All right. Okay, I'm back.
Alright, you're back? Okay. So I'm gonna move the string builder here. So essentially, I'm creating a string builder. So this will take care of all. This will make sure I don't have to create a new string every time I concatenate something.
Mm-hmm.
So that should reduce the runtime a bit. So if group 1 isn't 0, if it's greater than 0 essentially, then we convert group 1 into a chunk. So this would be, let's say here, this would be 1, 2, 3, so 123, and then we want to append the unit million, right? So first I guess we append a space, and then we append million. And then so is it okay to have trailing spaces?
That's okay.
Okay, so yeah, I'm just gonna do this so it's easier. So, and now I look at group 2. If group 2 is greater than 0, I convert group 2 as a chunk, and I append that to the string builder, and this time it's 1,000.
Mm-hmm.
And the last group, did I miss anything? So if the last group is group 3, if group 3 is greater than 0, I do the same thing, except this time I don't append anything at the end. And also one thing that I would amend later on is the and. So the keyword and, right? So sometimes
that's not required.
Okay.
Not necessary.
Okay.
Yes.
So and return string builder to string. I think that's it. That's the right convention. So let's walk through the example. Walk through with an example. So here, let's walk through 3 examples actually, like one
Okay.
or 2 at least. So one is where there's nothing in the other groups. And let's say do you think these examples are thorough enough?
I think so.
So these aren't.
There's one special case you're missing here. When it's 0 your input.
Right. Okay. So if group 3, I think I would add one case here. If the number itself was 0, then I would just return 0.
Mm-hmm.
And I would just
0, right? The 0.
Oh, sorry. Yep.
Yeah.
Yep. So okay. So let's look at this example. If it's 0, if num is 0, then we return 0. Okay, good. So 9. So the number is not 0, so we do all this. Group 1 would be 0 and group 2 would be 0 as well. Group 3, however, if you mod by 1,000, is still 9. So here, group 1 is not greater than 0. Group 2 is not greater than 0, so these are skipped. So group 3 is greater than 0, so we would convert group 3 chunk into 9, right? So it would be 9. So essentially, I'm just going to write it here instead of because when you append to the string builder, essentially you're just adding to what you're going to output. So this string, return string builder to string here. So you get 9, that's what we want, that's right. So let's look at 23,000. It's not 0, so we skip this. Group 1 is 0. Here. Group 2 is 23,000 mod by 1 million. That would still be 23,000 divided by 1,000. And we got 23 for group 2. And we got 0 for group 3. So, group 1, 0. Group 2 is not 0, it's greater than 0. So we append the chunk, we append group 2 converted to a chunk. We would get 23. And then we append 1,000. Group 3 is 0, we don't do anything. And we get the result 23,000, which is correct. 1 million. So we go through this again. The number is not 0. Group 1 is the number modded by the number divided by 1 million. So group 1 is 1. Group 2 and group 3 are 0. So if group 1 is not 0, then we convert group 1 into a chunk and append it to the string. It's 1. Now we also append the word million. Group 2 and 3 are 0, so nothing happens. So we get the result 1 million, which is consistent with our expectations. So I think it seems to work.
Okay, alright. Yeah, so let's stop here. I think it's overall solid. What the book does is this problem is 2 parts, right? So one is like kind of parsing the chunks into and trying to fit them into like thousands or millions.
Yeah.
And the second part is actually going into each chunk to figure out what the string is. So I think it was good that you got that. How the book did the chunk thing was through a while loop. And it added it to like a stack pretty much.
Okay.
So it did the tens place first, chopped off the last 3 digits, so divided by 1,000. And then it did the second chunk, which is the thousands place, chopped that off, and then it got the millions. And then it called converted chunk on the modulo 1,000 for all of them. So yeah, it just did it in a loop. Yeah, I think if we had more time, I would ask you to implement convert chunk.
Okay.
But I think you can take a look at that
Okay.
at your leisure. It's good that you use a string builder. And yeah, overall, I think it's solid.
All right. Thanks, Sean.
Yep.
All right. And that's it for today. Thanks, everyone, for joining us.
Yep. See you guys.